Welcome to The Explainer. Today we're diving deep into the world of decentralized finance. We're going to peel back the layers on a decentralized exchange, a DEX, and really see how trust gets built with code, not just, promised with words.
So this is the big question in DeFi, right? In a system with no CEO, who do you actually trust? I mean, there's no central authority, no headquarters to visit, no customer service line to call when something goes sideways. So where does the trust come from? Well, the answer isn't a person. It's not a brand. It's the code.
Yeah, this quote really hits the nail on the head. Smart contracts aren't just lines of code, they're the bedrock. So what does that bedrock actually look like? For this explainer, we're going to use the architecture of the Aster DEX as our roadmap to see how it's all put together. All right, before we get into the real nuts and bolts, we have to talk about why these smart contracts matter so much. I mean, why is looking at them so important? Because in DeFi, this is it. This is the ultimate form of due diligence. It's your window, your direct line of sight into the integrity of the whole system. Okay, so what is a smart contract? The easiest way to wrap your head around it is to think of a vending machine. Seriously, you walk up, you put in your money, that's your input. You press the button for what you want, and the machine is programmed to spit out a specific snack. That's your output. There's no clerk, no one to argue with. The rules of the deal are just baked right into the machine's code. And that, in a nutshell, is a smart contract. All right, let's pop the hood on this thing and see how the financial engine really runs. Now, you gotta understand, a DEX isn't just one giant piece of software. Nope. It's actually a whole collection of different, specialized smart contracts that all have to talk to each other and work together perfectly. It's like a team. So, at the core of this whole operation, you've got two key players, the Treasury and the clearinghouse. The easiest way to think about it is this. The Treasury is the vault. It's the super secure place where all the collateral is locked up. But a vault just sits there, right? It needs orders. And that's where the clearinghouse comes in. It's the brain of the operation, telling the vault what to do. And you can see that flow right here. It's actually pretty elegant. So, step one, you close a trade. Then the clearinghouse, the brain, remember, it does all the math, calculates the profit and loss, figures out the fees, the whole shebang. Once it knows what needs to happen, it sends a command over to the Treasury, the vault. And the Treasury, and only the Treasury, moves the actual money. It's a perfect separation of powers, and it's all automated by the code. Okay, but how are prices decided? This is where things get really interesting. A lot of DEXs use what's called a standard AMM. The problem there, as you can see, is that your actual money, your tokens, are sitting right in the liquidity pool. This can spread your funds thin. That's liquidity fragmentation. But here, they use a virtual AMM. And the difference is huge. The liquidity is virtual. It's only used to figure out the price. The real collateral, the actual funds, never leave the safety of the Treasury. And separating those two things, that's the secret sauce that allows for things like higher leverage and just being smarter with your capital. So, the engine's humming along nicely. But what about when things go wrong? Because let's be real, in crypto, things can go wrong fast. What happens if there's a huge market crash or a data source just stops working? Well, that's when the protocol's immune system kicks in. These are automated safeguards built right into the code to protect everyone when the market gets wild. The first line of defense is something called a dual consensus oracle system. Now, oracles are just a fancy word for services that feed real-world price data onto the blockchain. This protocol is smart. It doesn't rely on just one. It uses two totally different ones, Chainlink and Pyth, which work in different ways. Think of it like a championship game. You don't just have one referee, you have a whole crew. Here, you have two referees, and they both have to agree on the price before a big play happens. That makes it way harder for one bad call or one bad data feed to mess up the game. And the system is super strict about this agreement. It's constantly watching the prices from both oracles, and it has a very, very small margin of error. They can only disagree by 0.5%. That's it. Anything more than that, and the system starts to get suspicious. So let's play this out. Imagine there's a huge flash crash. The market goes haywire, and suddenly those two price feeds disagree by more than that tiny 0.5% threshold. What happens then? What's the protocol's emergency plan? Boom! The circuit breaker activates. It's an automatic safety switch that gets flipped. The system temporarily stops all major actions. No new minting, no liquidations, everything pauses. Why? To protect everybody's funds from being traded based on what could be bad data. It's like hitting the emergency brake to give everything a chance to calm down and stabilize.
Now, this immune system is also about handling planned changes, not just emergencies. The system is designed to be upgradable, using something called the UPS proxy standard. That's a technical term, but what it means is simple. The code can be improved. But, and this is a huge but, any upgrade has to go through a mandatory 48-hour time lock first. It's a waiting period. And that delay is a massive security feature because it gives the entire community time to look at the proposed changes and kick the tires before anything actually goes live. Okay, so we've talked a lot about the core engine, the security, the nuts and bolts. But how does this translate into stuff you can actually use? Well, this secure engine isn't just a cool idea on a whiteboard. It's the rock-solid foundation for an entire ecosystem of products. And this table gives you a great snapshot. You've got all these different products, right? Liquid staking tokens, yield vaults for different assets. They all do different things. One might be for staking, another for earning yield, but look at the common thread. They're all built on top of that same verified, audited, secure infrastructure we've just been walking through. They're all plugging into that same trusted core engine. And this really brings us to the most important point of all. In DeFi, real trust doesn't come from a flashy marketing campaign or a charismatic founder making promises on Twitter. No, it comes from the ability for you, me, anyone to go and look at the code ourselves and verify that it does what it claims to do. And that trust isn't just a feeling, it's built on 3 distinct pillars of proof. First, you have formal verification. That's basically a mathematical guarantee the code works as intended. Then, you have automated tools that scan the code 24/7, looking for any known vulnerabilities. And finally, and this one is so important, you have audits. Deep, intensive reviews by outside security experts, people whose entire job is to try and break things, to make sure the whole system is safe and sound. And that's the bottom line, isn't it? This whole approach, public, provable, layered security, this is what makes it possible for something as complex as a financial exchange to run smoothly and safely without a company or a CEO in the middle. The trust isn't just given, it's earned through total transparency and constant verification. So that leaves us with one final question to chew on. We've just walked through how you can build a complex financial system on top of verifiable code. So if finance can be built this way, on transparency and proof instead of on trusting opaque institutions, what else can be?